you'll come to someone and they say, okay, well, I want to figure out customer churn. And you're like, okay, well, I'll build this model, but I can't guarantee that it's going to be good. I can't guarantee it's going to be accurate in the first pass. But in the meantime, you have to figure out how long you're going to be at the client, how much value you're going to add. So it's very, very hazy.
You're listening to Gradient Descent, a show where we learn about making machine learning models work in the real world. I'm your host, Lucas Bewald.
Vicki Boykis is a senior consultant in machine learning and engineering, and she works with very large clients and brings a really interesting perspective on how they think about data science and machine learning. She also has a hilarious Twitter account and a really fascinating newsletter that we'll link to, and I'm really excited to talk to her today. So it's really nice to talk to you, Vicki. You know, could you tell me a little bit about your career and how you got into data science and where that began?
Yeah, it's been a really interesting career, I think. Not unlike a lot of other people, but a little bit different. So I don't have a comp sci background. I did an undergrad in economics at Penn State. And
Cool.
then I went into economic consulting, which was pretty unusual. And it was right around the time of the recession in 2007. So I was happy to find a job, actually, and even more so to find one in my industry. But that involved doing a lot of spreadsheets, tracking global trade movements, tracking internal projects, all that kind of stuff. So I started working with data analytics there. And then for my next couple of jobs, I worked in data analytics. And then for a job that I had in Philadelphia at Comcast, I started working with big data. So we had big data available, and there I started working with Hadoop and looking at big data and
What
more
year is
of,
it?
that was 2012, I want
Cool.
to say. Yeah, so right around the time that it was starting to get really big, started working with that tool stack, and that involved me having to get a lot more technical. So at the time, I was doing primarily SQL, had some frustrations with just doing SQL with Hadoop. Hive was still relatively new, a lot of growing pains there. So I started working with that stack. And then from there, I started doing more large scale data science sampling, programming, all of that, and then went on to my next job as a data science job. And I've been doing data science ever since, but ironically enough, I'm moving kind of away from data science now. And I actually wrote a post about this. I think the entire industry is moving a little bit in that direction. So not every job, but the industry on average, and more towards instrumenting the processes around data science. So creating machine learning pipelines, creating foundations and structures that are really solid and kind of go end to end. So I think there's still a ton of jobs that are just pure analysis, but as the industry grows, as the amount of data that we work with grows, I think the whole industry as a whole is trying to get smarter about replicability, and that's where I'm working in now, more in the machine learning engineering space.
So you think it's actually the bigger challenges now are becoming more engineering issues than analysis issues?
Yeah, I think I agree with that, at least from my perspective. So again, I'm a consultant, so I come into companies that kind of want to build out data science or data engineering platforms, and usually they're starting from. So usually the question will be, do we have data, or I'm sorry, let me rephrase that. They have a question about, let's say, are sales going up or down and why, and then we work backwards and say, okay, well, you actually don't have the data yet to do this,
Mhm.
and you don't have a platform stood up where you can reliably look at this stuff on a month to month basis. So
Mm.
that's where a lot of the challenges that I see are now.
Interesting. Is it maybe because you're going to companies now that are like a little bit further behind? Is that possible, or like kind of starting from scratch, or do you think like something's changing where people sort of expect to have a more built out processes and tools?
Yeah, I think it's the second one. I think if you look at the landscape of whatever the data tools landscape map that Matt Turk puts out every year.
Uh-huh.
So in 2011 and 2012, it was like a quarter of a page, and it was just like Hadoop. And that was it. And now I think poor Matt has to put together like 500 logos into a single page. And there's an orchestration area, and there's a tools area, and there's an area just for tools around Spark and all of that stuff. So I think people also, there's the expectation that if you have something, it should be productionizable.
Mm.
And even to the point where we now have notebooks, which are generally seen as like an exploration tool. There's also some movement. For example, Netflix recently has had around productionizing notebooks. So whatever workflow you're looking at, I think there's the expectation that in the end it be reproducible to be valuable.
I see. It's funny, my last company, we sold into a lot of the kind of Fortune 500, not necessarily Silicon Valley, and I always kind of really enjoyed seeing the different perspectives and like all the different um, applications. How has it been for you as a consultant? Does it feel more like frustrating or exciting, or I guess what is it like to kind of go into an organization and try to teach them how to how to build out these
Yeah.
processes?
I think it's a little bit of both. So it's interesting because consulting as a data scientist involves both, and I think this is actually true of all data science, but even more so of consulting. It involves both like the people piece and the technical piece. So you have to know what you're doing technically because you're the expert when you come in the company, and you have to say, okay, this is how we want to do the architecture. But you're also going to be talking to people who maybe don't want this process at all. You're going to be talking to people who are disorganized. You're going to be talking to people who are for it, but don't necessarily understand it. And so a lot of that work is actually talking to people and building the case for this stuff as well.
What does a typical stack end up looking like these days?
Oh, it's hard to say. So I've dealt with both companies, small and large. A lot of companies are increasingly in the cloud. So it's interesting. I don't think I have any GCP clients that I've dealt with. Um, AWS is, of course, probably the lead. And I did a Twitter question about this a couple months ago, like who's using what. AWS came out something like 60 to 70%. Azure, I'm surprised, is really catching up. I think even as little as 2 to 3 years ago, they were squarely in third place. No one was even considering them, but now it's really growing, and I think part of that is Microsoft's leadership, plus the fact that a lot of companies in the retail space are not allowed to use AWS because they see them as a competitor, and partially because they are stepping up their game in the tools that they're providing.
Is there a particular offering from Azure that you like or you think is kind of driving some of this growth?
I actually, ironically, I haven't used Azure a lot. Most of my work has been in AWS, but now that I'm seeing that people are more interested in it, I'm definitely going to have to start looking into it.
Interesting. What about like is there any tool that you think is sort of like underrated that, people like probably should be using or you recommend but people aren't using yet?
Um, I want to say Bash. That's kind of a
Gosh,
glib.
yeah. You live up to your Twitter reputation.
That's a really glib answer, but it's really true because a lot of the times when you come into these big, huge projects, you have 5 or 6 different AWS services spun up. You have GPUs, you have monitoring, you have all this stuff. And then you start thinking, okay, well, I have all this stuff. How am I going to use it for X? um, well, oh, I can't test this locally. I can't do this locally. I can't sample the data. What am I going to do with it? So I really do think, and I find myself falling into this pattern too, where you use all this big data stuff, but then you don't use the stuff that you have available to you. And it's even easier these days when a lot of us are working with pretty high powered machines that you can do a lot locally as well.
Interesting. So you run a lot of stuff locally?
Some, yeah, especially to test stuff, to prototype. And in cloud environments, it's really hard to spin up those local environments. So just even like to look at the data, to examine what you're dealing with, all of that stuff, so you can do locally, and you can Bash goes a long way towards that.
So I know that you can't talk about your individual customers, but could you kind of talk broadly about the sort of like questions that are driving the interest in more interest in data science right now? Like what's like kind of top of mind? Like what would you expect going into like another Fortune 500 company that the executives want out of their data science platform that they're not getting right now?
Yeah, so the number one question is always to understand customers and understand what they're doing and understand how what the customers are doing ties directly to the bottom line. And that manifests itself in a number of different ways. The one that I usually talk about, which I've also written a blog post about, is churn. Everybody always wants to know churn. So, how many people are leaving and why they're leaving your platform. and how much money it's going to cost you on a month-to-month basis. Everybody always wants to know that, and I can guarantee in any given project I'll see it. And then the second one is better understanding operational metrics. There's sometimes not a lot of insight into that. And the third one would probably be classifying customers into different types of customers,
Interesting.
creating
So, like,
segments.
what's like a deliverable that you would give a company around churn that they would be like excited about? Like, can you literally say I can predict churn like X% better, or is it more like, if you see this signal, then that kind of means churn? Like, how do you actually like present some kind of analysis?
Yeah, so Deliver, it would be literally a platform that has information to be able to predict what churn is going to be, for example, for next month. Usually what ends up happening is a lot of the things that I'll deliver are the data engineering piece around getting all the data all together in one place so we can have a data lake so we can actually deliver that churn piece.
Hi, we'd love to take a moment to tell you guys about weights and biases. Weights and biases is a tool that helps you track and visualize every detail of your machine learning models. We help you debug your machine learning models in real time, collaborate easily, and advance the state of the art in machine learning. You can integrate weights and biases into your models with just a few lines of code. With hyperparameter sweeps, you can find the best set of hyperparameters for your models automatically. You can also track and compare how many GPU resources your models are using. With one line of code, you can visualize model predictions in form of images, videos, audio, plotly charts, molecular data, segmentation maps, and 3D point clouds. You can save everything you need to reproduce your models days, weeks, or even months after training. Finally, with reports, you can make your models come alive. Reports are like blog posts in which your readers can interact with your model metrics and predictions. Reports serve as a centralized repository of metrics, predictions, hyperparameters tried, and accompanying nodes. All of this together gives you a bird's eye view of your machine learning workflow. You can use reports to share your model insights, keep your team on the same page, and collaborate effectively remotely. I'll leave a link in the show notes below to help you get started. And now, let's get back to the episode.
How sophisticated would a churn prediction model be today? Like, like, are we talking like, are people using like deep learning for this, or like how complicated do these models get?
I don't think I think a lot of times in companies, and even before I was doing consulting, like in all my previous jobs, people are just impressed if you can get a model out the door a lot of the times, in overall industry. So if you have something that you can benchmark against, it's seen as good, especially because there's so many steps in doing it. So first you have to collect the data, then you have to clean the data, then you have to go to the customer support team and say, does this thing, like, does someone calling in mean that the person might churn or not? And then you have to collect all the manual data that they keep and keep track of that. Then you have to build the model. Then you have to do a prediction. Then you have to meet with the people who are in charge of this and explain your data to them. And then there's going to be a back and forth there. And then you have to productionalize all of that.
Right.
So if you can get a model end to end going, and I've come into companies where there was zero data science before, and so that's why I'm saying that you have to build it from the ground up. Having that is fantastic, and just having metrics where there were no metrics before is a huge step up. And then the next step up is, of course, okay, well, why is this metric different this month? Why is this metric different that month? So a lot of the churn models I've built have been with pretty basic stuff like logistic regression and decision trees. I haven't seen any deep learning used for churn yet, but I'm sure that use case is around the corner.
Well, I mean, okay, here's a specific question. I mean, like decision trees versus logistic regression, they do kind of different things. Do you have a particular one you start with, or do you try both, or some kind of hybrid? How do you think about that?
Yeah, so again, depends on the data available. Usually, if also depends on who's going to be looking at it.
Mm.
Usually, if it's people at a higher level, like executives that need to briefly glance and understand something immediately. The decision tree is very intuitive and very easy to explain. And it can offer a number of different pathways for discussion. If you just need, some sort of model that spits out, is this person going to churn? Yes or no? Logistic regression is a little bit better for that, but again, depends on the stack that they have. There's different software packages that are better or worse for logistic regression. So for example, surprisingly, Python, as far as I know, does not have very good decision tree support. You could do XGBoost, which is not quite the same, but
Oh, so these
R
are
is
actually
actually
it's like multiple decision trees.
right.
It's like
Nested decision
you're doing
trees. Yeah.
boosted trees or something
Yeah,
like that.
boosted trees, but it doesn't offer like the nice visual interpretation, I guess, as much as the art part package. So yeah, it really depends on like what you have available, what you can do, all that kind of stuff. But I would say all any of three of those are my go-tos for that.
Interesting. So you'll build like a stable pipeline that includes R in it.
I've done it for stuff where I've had to prototype
I see.
and kind of like throw it out. I actually have not built an R pipeline in production, although I know it's very possible and increasingly becoming more and more possible.
Interesting. Do you see like do you feel like R is kind of like here to stay, or do you feel like it's getting replaced by Python? Like where
I
do you
mean,
look?
I think they're two different tools for two different things. So I think R is fantastic for statistics, for stuff that you're working on in probably smaller teams. Um, and Python is more like of a general, like if you need to glue stuff together and if you need to do deep learning and if you need to have stuff end to end, you'll use Python. But its basic statistical capabilities are not as good as a lot of the R packages.
Do you how do you think about leaving your work in like a state where like another person can update
Mhm.
it? Like how does that happen? Do you ever check back in with like a client and see if anyone's like touched your model and it's still useful for them, or that seems like it must be really hard.
Yeah, so what we usually do is we work side by side with the client. So we'll have a person on the client side who is a data scientist, so we can hand it off, or we'll have teams, and so we do education throughout the process, so we can hand it off and not just be like, "See ya," like this person knows how to pick it up and knows how it was being built.
I see. That makes sense. And you probably like pick the technologies they're familiar with, or do you
Yeah,
train them?
for sure. Yeah, so we try to pick technologies that are not foreign to the client, so it's not like they're completely floundering and gone when we hand over PyTorch or something.
So what's the biggest frustration in this whole process? Like where do you see the biggest room for like potential improvement? Like if you can, I mean, I think we've both, kind of sold into big companies, and
Yeah.
it's like, it's challenging. Like you don't want to say bad things about your clients, but also you do feel some like, come on, like this is ridiculous, guys. Do you have any
Yeah.
any patterns there?
I
In
think
case
the
any
biggest
Fortune 500 execs are listening.
so I think the biggest issue is trying to explain the benefit of machine learning in a way where it's not always exactly clear. So like for example, you'll come to someone and they say, okay, well, I want to figure out customer churn. And you're like, okay, well, I'll build this model, but I can't guarantee that it's going to be good. I can't guarantee it's going to be accurate in the first pass. But in the meantime, you have to figure out how long you're going to be at the client, how much value you're going to add. So it's very very hazy, and I think that's more of a frustration for me. But it's also like an educational issue where you're not going to always get to a right answer like the first sprint or the second sprint. It's going to be an iterative process, and sometimes like if you add stuff, the model will get worse. If you take stuff away, the model will get better. So it's kind of hard because data science is always sold, or like I see it being sold as this exact thing, but it's very much like an art process.
Mhm.
And so I think that's where some of the frustration is, like it's not an exact thing and people expect it to be.
And I can imagine it's probably really hard going in like a priori, not knowing like the amount of lift. If somebody's like, well, I for sure want this to get better. It's like, well,
Right.
without the data, how would you know?
Exactly.
How do
Yeah.
you like articulate that? So like if someone's like, hey, tell me like how much, you're going to improve my churn prediction. What would you say to that?
Yeah, that's a good one. I think first, I don't know. I've actually never had it happen that someone was like, "You have to improve my model by this much." It's usually like, "Let's create a model to
Uh-huh.
do X, Y, or Z." But what we usually do is benchmark against previous metrics that they have. And so the goal there is to say, look, we're not sure how much we can improve your model, but we can improve the process
Mm.
around the model so that it can be a little clearer.
When you look at like the kind of successful engagements where you feel like you really made a difference versus the ones that are kind of more frustrating, are there patterns like are there things that kind of your sort of more successful clients are doing around data science that sets them up for success?
Usually working in a tight loop with me. So a lot of the times the companies I work at will be bigger, and so the data science team will be on one side, the data engineering team will be on one side, the project management team will be somewhere over there. And
Mm.
so I'll talk to all of them, but they don't talk to each other necessarily. Um, and so what I've seen work best is when I'm embedded with a developer, a data scientist, a project manager that are all kind of working together towards the same thing because there's a big tendency to get siloed.
So I think like companies sometimes they debate internally about like should we have like a single data science function or should we sort of embed the data scientists and have the different kind of functional teams hire data scientists for the individual products that they're working on. Do you have an opinion that it sounds like you might prefer data scientists being sort of embedded in specific products that or specific outcomes, or do you think that it's better to keep it all as like a single function so you can maybe hire better people or create a better culture?
Yeah, I'm not really sure I have an opinion on that. I've seen it work well different ways in different companies. I think probably for smaller companies, I would say like less than 1,000 people or so, you probably want to have a centralized team. For much larger companies, you probably want to have embedded data science teams. But then the danger is if you don't manage them centrally, then you have 5 or 6 data science teams working on the same questions. And I've definitely seen this at companies where it's just replicated work and they're just approaching it in different ways.
Mm. So really, so you see sort of success in sort of both.
Yeah, yeah, for sure.
I see. Um, do you see like do you see like the like specific stages where you're like kind of prototyping something and then deploy it into production? It sounds like you're really focused on sort of getting things like stable and in production. But do you sort of like prototype the steps first and then solidify them, or how do you think about that? Like, what do you
Yeah,
have to specifically say to a client? Like, we're going to prototype and then we're going to deploy.
yeah, that's usually what we do. So usually I come into an environment and you're not really clear on what's going on in the environment at all,
Uh-huh.
right? You're just kind of thrown in and say,
Right.
okay, go. So the first step is to gather and assess what's going on. What tools are they using? Who are the key people involved in this? Gather all of that out and then start to create a model from whatever data that you have available, see if you can actually create that model, and then many sprints later take that model to production. It's usually never you come in, you create something, and then it's already running.
Got it.
It's usually a lot of human steps in the middle to get it to that point.
And so what's the biggest, like when you think about like kind of taking, I mean, I feel like everyone always underestimates the pain of taking like a prototype into
Yeah.
production. Like what are the biggest challenges that people might not expect or don't usually expect kind of going into that process?
Uh, um, Packaging the model is always a big one. How do you package
Interesting.
it?
So how do you typically package it? Like what are the options? How does that work?
You could pickle it.
Uh-huh.
You could create a REST endpoint from it. You could put the model in a Docker container and expose endpoints from it. I think that's something that I've seen happen more and more frequently,
Mm.
where the resulting output is essentially a web app or a web service,
Uh-huh.
and something hits that web service and you get an inference point,
Uh-huh.
right? Um, yeah, I would say those are the two two big ways right now. I think another big thing that people don't think about a lot is metadata management.
Mm.
And a lot of big companies want to do metadata management. In fact, I think almost every company that I've talked to over the last 5 years has said, we need some way to manage all the metadata in the data lake so that we can update the models and so that analysts can do the analysis. But there's no single tool for it. And I think only now have open source tools started coming out for it. Like, what was it? Amundsen? Was it Uber that came out with Amundsen? I forget. But there's at least a couple of companies that have like a metadata management. And so the metadata is which variables are in the model. When was this model updated? When was this table updated? All that kind of stuff. And surprisingly, people actually clamor for that more so than even visibility into how to manage the model.
And so this is you gave. I was kind of curious what you were going to say about like what the metadata is, but it sounds like you gave examples of like this. There's metadata about the actual input data, and there's also metadata about like what the model is actually doing. So it
Correct.
sounds like both are important.
Yeah. Yeah.
And
And yeah.
oh, go ahead.
Oh, I was just going to say, yeah, the biggest one is usually people create data lakes. They throw everything into unstructured environments like S3, and then they need to understand what's actually going into those environments and where it's coming from, which is where the metadata piece comes from.
And I guess what kinds of trouble do people run into from like not having like a like standardized metadata? Like what are the issues that come up?
Well, they wouldn't know, for example, which tables they can use for what, when those tables are being updated, how much, like whether those, a big thing for big companies is whether that data is proprietary or not, whether they're actually allowed to use it. There's all sorts of controls around PII.
Mhm.
All of that kind of stuff. And then usually for that data lake, analysts will also want to query it and they won't know what's in there at all.
Uh-huh.
So it's another way to surface it in a way so that it doesn't impact production. So when analysts are hitting it, for example, they don't hit like the entire Redshift table or the entire thing in BigQuery.
I see.
It's just they know what the data is, what's available, and what they can take from it and what they can't.
And so are most of the models that you're building, are they running in kind of like online mode, or like do they kind of run offline in batches, or um
A mix. I would say most of the models that we built for clients are online,
uh
or I'm sorry, are batches. I'm working on a personal project now that's online.
oh, cool.
So
Can
it's
you say
yeah,
what it is?
yeah. I'm actually almost done with it. So I'm working on learning GPT-2.
Uh-huh.
And so it's like a medium think piece generator.
Oh, nice. Oh, no.
Yeah.
That sounds too dangerous to release.
Yeah. Um, yeah, so the idea is that you put in like the first few sentences of a VC blog post in there and it
Uh,
generates like a medium think piece for you. So hopefully that'll be online. But my inference time is 5 minutes right now. So maybe it won't. We'll see.
oh, man. Um, do you do any kind of like monitoring of these models? Is that like an issue? Like, because I could sometimes people talk about like,
Mhm.
oh, the input data changes and nobody notices, and then the model gets broken and nobody notices. Is that like a real issue that you've seen?
Yeah, so a lot of I think we're just starting this as an industry. I know there's a lot of talk about observability and catching model drift, and some of the larger companies, like the FANG companies, are really ahead in that space. In general, I would say it's very much an all unsolved issue, and people usually still resort to checking the database and making sure that the data going in is okay. And that's kind of like the level of checking where we are. And I think people are just starting to say, okay, well, this is where the model was yesterday. This is
Uh,
where it is today, and this is where it should be tomorrow.
gotcha. Um, Well, okay, I have a question I've been kind of dying to ask you, but it's
Oh,
kind of
sure.
a little bit of a non-sequitur. So I love like working with people that know Bash, because I'm always embarrassed about my Bash skills, and I feel like I always like learn. Do you have any like favorite Bash command that people might not know about since you said it's your favorite tool?
No, I didn't say it was my favorite. I said it was an overlooked tool.
Overlooked tool.
I don't consider myself like a bash guru by any means,
No, but
but
neither am I.
I
Like, what's
turned
one
to
that
it
like you learned like in the last year, and you're like, well, that's a cool
in the
bash.
last year. Xargs, it
Sorry.
lets you,
Yeah,
it lets you
explain
do
that. Yeah.
parallel processing of a lot of stuff. So you can like simulate two processes.
Oh, cool.
Let's see. Cut is one that I use a lot. Cut and unique K basically lets you do like a count star from a database type situation. Um, yeah, I would say those are like my most
What are your
commonly used
go-tos?
ones.
Nice. I
Yeah, my
love
go-tos.
it. Cool. Well, yeah, we always end with a couple questions. I mean, we've touched on some of these, but I'd be really curious to kind of hear your perspective on this. So, what's like an underrated aspect of machine learning that you think people don't pay enough attention to?
Mm, I think I touched on this earlier, but like the people part of machine learning, if you are able to get more data or better data from people rather than banging your head against a smaller model, that's always going to go better than trying to figure out like an advanced model for it.
You've also touched on this a fair amount, but I'm curious how you'll synthesize it. So, what is the biggest challenge of machine learning in the working in the real world right now?
Putting stuff in production.
Putting stuff in production.
Putting stuff in production, yeah.
And like within that, what's the hardest part about putting stuff in production?
Oh, because there's so much that you need to get right in order to make, because it's not just like a software system. Well, it's it's just as complicated, but even more, because software is you have a piece of code, you put it in Docker, you put it somewhere and it goes. This is you have to keep track of data that's flowing in from Kafka or Kinesis or streaming. You have to make sure that all of that data is correct. You have to make sure it's serialized in the right format. You have to make sure that the database that the data is streaming into processes it correctly. You have to check all of that data. Then you create your models. Your models might work one day, you might get drift the next day. So you have to plan for that. And like I said, I think we're still in the early stages of planning for that. Then you have to expose your model to some service or some endpoint that's going to consume it. The model piece itself, you have to put somewhere like Docker or whatever. You have to make sure to orchestrate all of that. So this is very similar to software, except, and so I think we, like in modern software development, we have a lot of pieces of the stack that we're now responsible for because of DevOps. So DevOps means like, in theory, it's supposed to make it easier for you, but what it means is that the software developer also now has to be a sysadmin and understand some of those pieces. And the cloud brought in the fact that you also now have to be a network expert. So actually, a lot of my issues are troubleshooting, like why can't this service connect to this service over the company firewall? Basically. So there's all of that, and you have to know the data, and you have to know how the model that you're creating works. So putting that all together in production is really hard. And so I would say that's the biggest thing.
Well, well said. I have a feeling a lot of people listening to this podcast are going to want to hire you. um, so if that's the case, where can people find you? What's the best way to reach out besides, well, maybe it's Twitter where you're absolutely hilarious.
Yeah, Twitter is the best way. I'm just at VBoykis, VBoykis. And I also write a newsletter called Normcore Tech about all this kind of stuff, data, and a lot more.
And I can vouch for the newsletter personally. I'm a long time subscriber, last 6 months subscriber since you
Cool.
mentioned it on
Thank you.
Twitter, and I definitely enjoy it too. So it's an honor to talk to you today.
Thank you. Thank you for having me.
Thank you.